Okay, guys, let's do the remaining questions in this last video for 12.2. Number 20. How many ways can Nick Fury assemble a team of 5 Avengers out of 100 available superheroes? Okay, here he's not specifying that there's any position, there's no ranks or anything like that, or even roles, just choosing 5. So that's just a straight choice function. And choose R from the 100, always the bigger number first, yeah? Because it's not possible to choose a bigger number from a smaller number. 100, and I'm choosing 5 of them. Okay, let's just punch that in. 100, choose 5. So the N is 100. The R is 5. The answer is 75287,520. 75 to 87, 520. 75 to 87, 520. Did I remember that correctly? Yeah. Okay. So huge number. Yeah, it is surprising like how big these numbers go, but the permutations even more so grow way faster even. 221. There are 9 employees in the club. How many ways can they choose a dishwasher and a bouncer? Okay, these are distinct positions now, right? Distinct roles, distinct positions. Probably your dishwasher is not typically gonna make a good bouncer. Bouncer might be good at washing dishes. I don't know. But because they're distinct positions, that makes it a permutation question. So NPR from 9, you're choosing 2 of them and permuting because you care about the order now. You care about the position. So 9, 2 with an NPR function. So N is 9, R is 2. This time I'm checking the NPR result, which is the 72 value, not the 36. So 72. Number 22. How many ways can 3 aces be taken from an ordinary deck of cards? For this question, we're assuming that only 3 cards are taken. How many ways can 3 aces be taken? Okay, so this guys this is a question that people often get wrong, very often. So I'm giving word of caution, and you see a question like this on your homework too, I believe. So pay very close attention to this one. Try it out first, actually, and because what may happen is you might get it wrong when you try it out, which is the perfect time to learn because your brain is primed to learn when you make a mistake. So try it out first. I'm about to tell you the answer. Okay, let me first tell you what is a common wrong answer. Okay, common wrong answer. Common wrong answer is today. Okay, there's 52 cards, and I want to choose 3 of them. So 52 choose 3, right? Wrong, because what is this representing? This is saying from all 52 cards, I'm going to choose 3 of them. And they could be any cards. They don't have to be aces. So this is wrong. Okay. Sad face for being wrong. Okay, so what is correct? And this is a little counterintuitive, but it's much smaller than you might think. How many ways can you choose 3 aces? There's only 4 aces. So the big number should be the 4. And you're choosing 3 of them. Now, why am I doing choice function? Why NCR or the combination and not permutation? Well, because if I'm choosing 3 aces, I don't care what order they come in, just that I got those 3 aces. Okay, so it's 4, choose 3. And without even having to, this is small one, easy one. Top number is only 1 bigger. I know this is just going to be 4. What are the 4? I can actually write it out for you here. So I can have, what are the 4 possibilities? Choosing 3 at a time. I can have the ace of spades. Oh my gosh, that's terrible. Ace of, let's try that again. That's not any better. Okay, it's getting worse. Sorry, guys. Okay, ace of spades. Ace of clubs. Which my spade and club, sorry, look very similar, but. Oh, you know what I should do, guys? Let's use letters instead. Because my. Or maybe I'm just gonna draw bigger. Yeah? Okay, so I'll show you the first possibilities. Okay, ace of spades That's a little better. Along with the ace of clubs. Okay. I'm taking an unnecessary amount of time drawing these pictures. And ace of diamonds. Okay, so here's three choices, right? That's one possibility. Okay, I'm gonna circle this as one of the four possibilities. Okay, what's another possibility look like? Okay, I could have the ace of spades again. And the ace of clubs again. This time with the ace of hearts instead of diamonds. Okay, if you're not familiar with cards, guys, then you know, we are gonna mention this in a future class. Yeah, for sure, actually. But for now, you can just look up what are the cards. Look up standard deck of cards. You see all the cards, what they look like. Okay, but what you need to know, there's four aces. Yeah, there's an ace of spades, clubs, diamonds, and hearts. So those are the four different ones. If you don't want to think about aces in particular, just think of four of anything. Four numbers, 1, 2, 3, 4. Four letters, A, B, C, D. Okay, what are my other options? I could have ace of spades again. And now I can't choose clubs because I already have all the options with clubs, so I'll have to have the two other red ones. Ace of diamonds and ace of hearts. Okay, that's third choice. The final choice is to have the... Okay, I can't use spade again because I have all the possibilities. I have a spade. I can use clubs. And then that leaves me no choice but to have... Because I have all the options with spades already. Ace of diamonds, ace of hearts. Okay, so I had all four options. And that is in line with my choice function solution there, right? Without having to make the list. 4, choose 3, give me 4. All right. Now let's erase all that hard work to make space for the next question. All right, 23. How many ways can you draw a 5-card poker hand? Okay. This time, this would have been the correct answer. See this that we had a moment ago? This right here? That was the wrong answer for question 22. But for question 23, it's actually exactly what we want. No, it's not. I'm sorry, I lied. Close though. What is it? Poker hand is just any 5 cards. There's 52 cards in a deck. And I just want to choose 5 of them. I'm sorry, guys. I've been using this notation. I know a lot of us might prefer the NCR notation, but it's the same thing. Okay, so NCR 52, 5. I just noticed too, you know, the last times we'll write like this instead, right? 52, choose 5 like this. So these are all different alternative notations. This one, right? Oh, sorry, my volume button is just going crazy. This one over here is, I just read it like this because that's how we entered into the calculator. But I'll accept any of these notations. Oh, sorry guys, this thing is killing me. This iPad. Okay, so 52, choose 5, yeah? Let's type that thing in. And here's 52, R is 5. And I'm looking at combinations, so this is the second number. 2, 5, 9, 8, 9, 60. 2, 5, 9, 8, 9, 60. So that's 2,598,960. So it kind of shows you like maybe some of the interest of the poker hands. Yeah, like how many possibilities there are. Wow, over 2.5 million. Okay, 24. How many ways can you draw a 5-card poker hand and then arrange the cards from left to right? Okay, so now not only do I care about the 5 cards, but that word arrange means I now care about their order. So instead of being 52, choose 5, it's going to be 52 permute 5 now instead. Permute 5. Or in PR, as we would enter it into the calculator, 52, 5. And that's the other number I had on screen here, right? This number, 311, 875, 200. 311, 875, 200. So this time that's 311,875,200. Wow. All right, guys, we're nearing the end. Group of 30 students, how many handshakes are needed for each person to shake hands with each other? Oh, interesting question. So here, we've got 30 students, and I'm just choosing 2 at a time. So what this is this NCR question, just choosing 2. If I choose person A and person B, or if I choose person B and choose person A, it's the same thing, right? AB is the same as BA. Either way, they're both shaking hands. So I don't want to double count by rearranging. I'm only choosing, just NCR. From the 30, choosing 2 of them at a time. How many ways can I choose 2 people from the groups of 30? So 30 choose 2. N is 30. R is 2. And NCR was, in that case, 435. 435. That's how many handshakes. Okay, last questions. A bit harder. Not something I would ask on a test or a homework even. So just something to think about, try out. Try it out on your own as usual, but I'm going to tell you the answer. Okay, 26. Group of N students, how many handshakes are needed for each person to shake hands with each other person? Simplify as much as you can. Okay, so it's kind of a follow-up to the previous question, right? So 26. I'm going to write it down here. Answer down below. So for 30 students, remember we had NCR 30, 2, right? For 30 students. Now if I have N students, I'm just generalizing that. NCR, that's going to be N, 2. And then what I'm going to do to get this as simply, to have it as simple as I can, simplify as much as I can, I'm just going to write it out into the formula. Formula is N factorial for N minus R, in this case N minus 2 factorial, and extra 2 factorial. So I'm going to write this out, N factorial, N minus 2 factorial. Actually, no, let me do this. N factorial, instead of N factorial, I'm going to write N times N minus 1 times N minus 2 factorial. And once I hit N minus 2 factorial, I'm going to stop because that's where it matches the bottom here. So N minus 2 factorial. And then 2 factorial. Well, these guys right here cancel out, yeah, because they're the same. Leaving me with N times N minus 1 over 2 factorial. But 2 factorial is just 2. So in the end, I have just N times N minus 1 over 2. By the way, this formula here, this tells us the number of ways for handshakes, right? I actually remember like this one time when we were at a party or something, and then we were leaving, everybody was leaving, and then I noticed that everybody started to hug every other person, and we were all kind of like single friends at that time. So, you know, like, cause you don't normally like hug your significant other if you're out with other people, right? That would be weird. But because everybody's single, we're all hugging everybody else, and I was like wondering to myself, how many hugs just happened just now? And I thought to myself, oh yeah, it's just N times N minus 1 divided by 2. So I think there's about 10 of us. 10 times 9 divided by 2, which means 45 hugs took place at that time. All right, that's it. Okay, 27. Is N choose R equal to N choose N minus R? Can you prove or disprove it? What did your intuition tell you guys? What do you think? So here are a couple examples you've seen like of this before, right? Where 10 choose 2 is the same as 10 choose 8. We saw that happen before, right? We also saw, what else did we see? What is it? Foreign. I'm trying to look at it. I remember there's a question earlier we had about the same kind of thing. Was it way back here? Yeah, 10 choose 2, 10 choose 8. That's question 10 and 11, right? And then, oh yeah, number 19. Number 19. We had 12 choose 4 is equal to 12 choose 8. Yeah. So those are examples of it working. And if you could choose a million examples, after a million examples, what you'll see is that it always seems to be equal. But that doesn't constitute a proof. A proof is something more general. So here's the proof, guys. Proof is to write out both. So what n choose r is n factorial over n minus r factorial times r factorial, right? We knew that already. That's just the repeat of the formula exactly. Okay, what about n choose n minus r? What is that? Okay, same according to the same formula, it's n factorial on the top. And then the bottom is n minus r factorial. And then n minus r factorial, because this would be the place of the normal r, right? Okay, well, this can simplify. N minus r, that's the same as n. This negative sign will distribute, right? So it'd be n minus n, and then minus times minus is plus. So n minus n plus r factorial. And of course, n minus n is just gone. Those guys cancel. So I'm left with n factorial over r factorial, n minus r factorial. And look, this guy, okay, this is I apologize for this crazy equal sign. It's okay, guys. We're saying this is the equal sign, okay? Look, that's the same, right? Because the only difference is these two are switched order, but multiplication is commutative. So it's the same. And so I've proven that n choose r is equal to n choose n minus r. So there it is. Can you prove it? Yes, it is true. Yes, can. And we just did. Okay. Like I said, guys, these are not questions that I expect you would have to do. This is just more for enrichment and more for just like, I think they're interesting and kind of cool. So last question. Last question is kind of like the same question as 27 in a way, but it's asking, is the same phenomenon true for permutations? Right? This is NCR NCR versus NC n minus r. This is NPR versus NPN minus r. So if I just replace the C with a P, is it still true? And in this case, what's your intuition tell you? Yes or no? Well, the answer is no. So we're gonna disprove it. How do you disprove it? Disproving it is actually much easier. You just have to find any counterexample you want. So I'm just gonna choose random numbers. Actually, let's choose the same too. Let's choose 10 and 8, see if it works. So what's 10 permute 2, and what's 10 permute 8? Are those gonna be the same? Well, let's check with our calculator. Ten 2, I get 90. 90. What about 10 8? Change this R to an 8. Oh, whoa. Got 1,814,400. So, no, not equal, right? This is when, by the way, just to clarify, this is for when n is equal to 8, r is equal to 2, which makes n minus r equal to 8 minus 2. Oh, I'm sorry. 10 minus 2, which is 8, right? So this would be the 8. This would be the 10. The r would be 2. This n would be 8. 10, sorry, 10. Yeah, 10. So, yeah, not equal. We just disprove the fact. As long as you found one counterexample, that means in general they cannot be equal. Sometimes they might be just by luck or by chance, but in general they are not equal. Okay, this thus concludeth 12.2. Have a great day, guys. See you in the next section.